Hello everyone and welcome back to my YouTube channel. Today we are going to continue by solving more examples on algebra. So still on engineering maths, the fifth example will be simplify x squared root y times root x cube root of y squared all over x raised to power 5 y raised to power 3 all raised to power what? 1 over 2. So this is our first question or first example we'll be working on. Then before we move to the next example. So let's go. Alright, so we are given this question here. So what's the first thing to do? Take note, everything inside this bracket is multiplying everything inside this bracket. And if you check, the both of them are what? They have similarities. How? X is here, X is also here, Y is here, Y is also here. So we can assume or we can say that they have the same what? Basis. And we say whenever we are multiplying with the same base, we what? Add their what? Powers. But the issue we have here is that y root y, we don't know the power yet. We just saw root y, and cube root of what? Y square doesn't have a power. Root x doesn't have a power. So we'll write it in index form using our knowledge of the laws of indices, so that they'll all be in the form of their powers. So we'll have that what? X square root y will be same thing as what? Y raised to power 1 over what? 2 times root x, same thing as what? X all over 1 over 2, and cube root of y squared, same thing as what? Times what? Y raised to power what? 2 over what? 3. So in case you don't know how we got this 1 over 2, we have made a video in our previous class, and we say that what? Y raised to power 1 over 2 is the same thing as what? Square root of y. That's using the what? Fractional index law. And we also say that y raised to power what? Minus 2 is the same thing as what? 1 over what? Y square. You see the difference? This is using the what? Negative index law, while this is using the what? Fractional index law. So whenever you see a fractional index, you are simply taking the root of that base, that's y. And whenever you see a negative index, you are simply putting it in fraction form. We use this in this question, so take note. So this is how we got what? Y raised to power 1 over 2 and what? Y raised to power 2 over 3. So all over. Also, we know that y raised to power 2 all raised to power 2 is same thing as what? Y raised to power 2 times 2, which is same thing as what? Y raised to power 4. We did this in the power of power rule in our previous videos. We have a playlist where we've made videos on the basic operations of the laws of indices. You can go and check it out. So now for the denominator, we have x raised to power 5 and y raised to power 3 all raised to power what? 1 over 2. So it's the power of a power law we apply here. So if we want to open this bracket, we'll have that what? X raised to power 5 all over all raised to power what? 1 over what? 2 times y raised to power 3 all raised to power what? 1 over what? 2. You see, so this is now the same thing as this here. So from here we can further break it down as what, or let's rearrange them. Let's rearrange them first. So this x raised to power 1 over 2 will come close to this other x because they are the same base, and this will come closer to this other one because they are the same base. So if we are rearranging, we'll have that what, let's bring it down here. Rearranging, we'll have that x raised to power 2 times x raised to power 1 over 2, let's put it in a bracket, multiplied by what, y 1 over 2 times what, y raised to power what, 2 over 3. Let's also put them in a what, bracket, all over this now will now be what, x raised to power 5 times what, the power here, that's 1 over 2. Remember, we are applying the power of the power law. Let's put it in a bracket. And similarly, y raised to power 3 times what, 1 over what, 2. So here we can say that we have x raised to power 2. You know, when we are adding, when we are multiplying, we add them because they have the same base. You see, the same base. So since they are multiplying, you what, simply what, add their what, powers. You add their powers. This is the power here, 2 and what, 1 over 2. So it will now be 2 plus 1 over what, 2 times what, y 1 over 2, similarly what, plus what, 2 over 3, plus 2 over what, 3, all over what, 5 times 1 over 2 is simply what, 5 over 2. It will now be x raised to power 5. Oh, it is too big. It will now be x raised to power what, 5 over what, 2, and y, we didn't put this in bracket, y 3 times 1 over 2 is same thing as 3 over 2, right? Y raised to power what, 3 over 2. So they are all having their powers. So remaining the what, numerator. So we now have that x raised to power 2 plus 1 over 2. That's 2 plus 1 over 2. Let's bring it out here. 2 plus 1 over 2 is simply what? 2 over 1 plus what? 1 over what? 2. So if you take the LCM, LCM will be what? 2. 2 divided by 1. 2 divided by 1 will give us 2. 2 times 2 will give us 4. Write it here. Then here, 2 divided by 2 will give us 1. 1 times 1 will give us what? 1. So it will now be plus what? 1. Which will now be equals to what? 5. 4 plus 1, that's 5. over what? 2. So that's how we do our addition. So we have x raised to the power what? 5 over what? 2. Similarly, okay, if we want to add y raised to the power 1 over 2 plus 2 over 3, we can do that here. 1 over 2 plus what? 2 over what? 3. So if we take their LCM, we'll have that 2 and 3. The LCM of 2 and 3, let's do LCM for those that have forgotten. 2, 3. So 2 here, 2 into 2 will give us 1. Here will be what? 3. And 3 into here will give us 3 into here. Still be there. Will still be same thing as what? To come down. 3 into 3 will give us what? 1. So it will now be 3 times what? 2, which will give us what? 6, right? So the LCM here is what? 6. Then if we do 6 divided by 2 here, we get 3. And we'll do 3 times 1, we'll have 3. Similarly, if we do 6 times 6 divided by 3, we'll have 2. And if we do 2 times 2, we'll have what? Plus what? 4. So 3 plus 4 will give us what? Equals to what? 7 over what? 6. So we have that what? Times what? Y raised to the power 7 over 6. Just like this. This is how we got 7 over 6. All over what? X raised to the power what? 5 over 2 and what? Times what? Y raised to the power what? 3 over 2. So from our law of indices, we know that whenever we are dividing, we what? Subtract the powers. And since the same base is on the numerator and the same base is on the denominator, we can simply what? Divide. So if we divide, we have that x raised to the power what? 5 over 2 minus, you see, what you, this and this now same base, so you what? You what? Subtract their power. You subtract their power. Minus what? 5 over what? 2 times what? Y raised to the power what? This is 7 over 6 here. 7 over 6 minus what? 3 over what? 2. We have that what? X is into 5 over 2 minus 5 over 2 give us 0 times what? Y. So we have that 7 over 6 minus 3 over 2. Let's do it here. 7 over 6 minus what? 3 over what? 2. If we take the LCM like we did before, take the LCM, we have 6, we have 2. We take 2 here, come here, 6 divided by 2 will give us 3. And we take 2 divided by 2 give us what? 1. We go again, take another 3. 3 can divide this one. So 3 will enter here 1, and here will still remain as what? 1. So 3 times 2 will give us what? 6. So that's how we get our LCM. So if we write 6 here as our LCM, 6 divided by 6 will give us 1, and 1 times 7 will give us 7. Similarly, 6 divided by 2 will give us 3, and 3 times 3 will give us what? 9. So we'll have what? 7 minus what? 9. So if you divide, this 7, there's a plus here. So plus times minus will give us minus, plus 7 minus 9 will give us what? Minus 2. Because you're owing 9 naira and you have 7 naira. If you pay your debt, you will still be owing what? 2 naira. That's why we have minus 2 here. All over what? 6. Right? All over the denominator 6. That's 6 here. So if you cancel out, we'll now have what? Minus 1 over 3. Because 2 can go in here, 2 can go in here to get 3, 2 can go in here to get 1. So we'll now have y raised to power minus what? 1 over what? 3. And we know that from, let's write it here, our previous video, any base or number raised to power 0 will give you what? 1. So x raised to power 0 will be 1 times what? Y raised to power minus what? 1 over what? 3. So we will now have that 1 times y 1 over 3 is equals to y into what? Minus 1 over 3. Now, remember from here we had that y, that's here, we had that y raised to power minus 1 over 2 was the same thing as 1 over y raised to power 2. So similarly, y raised to power minus 1 over 3 will be the same thing as what? 1 all over what? Y into 1 over what? 3. You see? So that's what it means. The negative index simply means what? Put it in a what? Fraction form. So this will now be equals to what? From this y1 over 3, we know that y1 over 2 is same thing as what? Root what? Y. So y1 over 3 will be same thing as cube root of what? Y. So let's write it down. So our final answer will be what? 1 all over what? Cube root of what? Y. So this is our what? Final what? Answer. So the next example we'll be solving, I will introduce you to what? Bracket, factorization, and precedence. So we'll just solve one example, that's example 6. Then in our next class, we'll continue with more what? Examples using the what? Precedence, that's the BODMAS. So for this, the first step we have to do, say we should simplify a square minus 2a minus ab minus a into 3b plus a. So the first thing is to what? Open the what? Bracket. So if we're opening our bracket, we'll have that a square minus what? 2a minus ab minus what? A times 3b, that will be 3ab. It will be 3ab because here there's no a and here there's a. So we cannot say we want to what? Add their powers or subtract their powers because they're not common bases. So they will just join to become what? 3 what? A what? B. But for this now, a minus a times plus a, first of all, minus times plus will give us what? Minus. Then a times a, here a is raised to power 1, here a is raised to power 1. So a times a is simply what? A raised to power what? 1 plus what? 1, which is same thing as what? 1 plus 1 is what? 2. So it's supposed to be a raised to power what? 2. So we have what? A raised to power what? 2, right? So we successfully what? Removed the bracket. So next up, we are going to what? Collect like terms. This is going to be what? A square, right? A square is here, a square is here, minus what? A what? Square. This is supposed to be plus, sorry. Minus AB minus what? 3 what? AB plus what? 2 what? A. So we'll have that A minus A square minus A square to cancel out. Then minus AB minus 3AB. You're owing 3AB and you still have another depth of what? 1AB, because there's an invisible coefficient 1 here. So if you add your depths, you're owing 3 from one person and you're still owing 1 from another person. So 3 plus 1 will be 4. So since you are owing to be what? Negative, it will be minus 4AB, then plus 2A plus what? 2 what? A. So if we check what is similar between between both of them, we have that A is similar. We also have that 2 can go into 4 to get 2 and 2 can go into 2 to get 1. So we can factorize and have that what? 2A, it will be into what? 2A divided by 4AB. A will cancel A. 2 will divide 4 to get 2. So we'll have what? 2. And what will be left here, since A has cancelled A here, it will be B. So it will be 2B. Don't forget the what? Negative sign. That's negative here. Plus times minus will give you minus. Then 2A into 2A will give us 1. So it will be plus what? 1. So this will be our what? Final answer. So we are done for today. If you enjoyed this video, please kindly like, share, subscribe and turn on your notification so that when we drop new videos, you stay what? Engaged. So see you in our what? Next video. Thank you.